Johnson Space Center, and I've been with the Space Architecture Technical Committee for 10 years now. So I've learned a lot from the architects as an aerospace engineer, and I consider myself a space architect as well. So I'm bringing this knowledge to the ground tests that we're having for Gateway as part of the next step ground tests. So I'll be giving you a little overview of what the next step is, the goals that we wanted to accomplish with these ground tests, the test methodology, and how flight operations supported these tests. So first of all, we had the first phase of next step that started 2015, and where we acquired a lot of concepts from different companies just to see what we can do, if we can actually get there. It was just concept descriptions. Once that phase was completed, and now we are in phase 2, where we are working with the commercial companies that won the first phase and added a few more to look at the definition of their concepts, how else they can be, they can help us get to Gateway and all the other goals that NASA has. So right now we're defining the habitat architecture and the test definition for how we're gonna perform this. So as part of the ground test, it's to look at the different capabilities that each of these concepts can provide at different levels. So we're looking at getting the prototype units for testing and integration, but looking at the volumetric parts. Not only just the design like we saw earlier, but how the human can integrate with the things that they're going to be doing, all the activities that they're going to be looking into. So the goals for the ground test that we started last year and still continuing this year, it was to engage the stakeholders and subject matter experts from different parts of Johnson Space Center as well as other NASA centers. So in the traditional architectural system that we had, it was the designers to finish their design, then they pass it through the wall to the assembly and test, and then to operations. But we want to break those silos. We have to be working together from the beginning and avoid a lot of the mistakes that we've been doing either for the International Space Station or for other platforms. So that's why we're getting involved early in the design, even before the design, to manage these ground tests as well. So from these tests, no major design decisions were made. The main goal was to prepare the testers ourselves and prepare the infrastructure for those upcoming tests. And why we're doing this is because we're using this approach of human systems integration. Anyone heard of this before? If you haven't, please research it. You can find this Human Systems Integration Practitioner's Guide online. And is by NASA. This actually started from a Human Systems Integration Employee Resource Group that we have at JSC, and now it's becoming part of our daily operations. So HSI is an interdisciplinary technical and management process to try to put into consideration the limitations and capabilities that humans have. So it has 6 domains. The DoD, Department of Defense, was the first government agency, agency that needed to that put this together. But for NASA, we align towards human spaceflight. And this is also rolled into the Systems Engineering Handbook. So I invite you to look into those as well. So you're going to say, where do I use HSI? We have on this, you might have seen before, is the life cycle phases that NASA uses for from pre-A concept studies to close out phase F. Then we have the reviews, and in the bottom part we have the HSI activities. So as you can see, all those activities are really going across the entire life cycle system. And that's what we need to do with including different evaluation methods like the human in the loop evaluations. This is just a picture of an example where we were testing the crew survivability methods that astronauts will use for the Orion capsule. That's just one example, looking at how much the astronauts can reach, can they actually get out from the capsule, if they're going to step onto something. Those are all considerations that we need to be looking into, and we're going with that approach for Gateway early on. So first, the test objectives are being considered in a formal way we're in a database. We're just using SharePoint, trying to enter all the descriptions of the test objectives for each subject matter expert, and how we're going to be doing that evaluation, what we're going to be getting out of it. So all these activities, the commercial partners are going to be putting into, are going to be using it for their tests. What we're using is a facility within JSC. It's called Building 29, and that's where we have the IPAS, or Integrated Power Avionics and Software Lab. And you see, this is an early stage. That's from last year. Now we have covered that. But that's the original habitat markup, and it uses Orion will be in the side, and now all this area will be for the testing operations, subject matter experts that we want to have there. Like I mentioned, this is a collaboration between different NASA centers, so a lot of them are putting a little bit of effort on making these tests happen. The architecture, it's pretty easy. We have the IPAS lab, the simulating gateway, and Orion talking to with telemetry, talking through JPL, and also getting it through MCC, and that comes to me. And then we send the commands same way to communicate with the astronauts on gateway. This is a little bit, a few pictures of how it looks, like the structure itself, and now this is just something that we would like to be looking into. So this, at the beginning of this year, we did a little bit more enhancing pictures for this, so this is not the latest. But this is how it looked like for the initial test, the configuration that we had. And the objectives that we had for flight operations specifically were in the planning side. A lot of the crew activities dictate how the crew or the designs of their interior of the structure, the habitat is going to be. So we wanted to address the activity requirements for subject matter experts depending on the activities that they were going to do, either science or exercise, etc. And how we can uplink procedures going from the mission control room to the HAB simulator and to Playbook, which I'm going to be talking a little bit more about later. We also have command telemetry and voice, if we can communicate, send commands, and can get the response fast enough. And we wanted to provide a flight-like test experience, not only for the crew, but also for all the ground control team, because we need to be prepared for that. So we use a tool that is called Analog Score, where we build the plan for the different activities that the crew will do and also the ground. This is very simple compared to the International Space Station activities, and you can look that up too. So it's a smaller version, but what takes work is to come up with a right structure, because we're looking at spatial constraints, we're looking at temporary constraints, and if one activity needs to happen within half an hour or after exercise, all those temporal constraints, spatial and volumetric constraints, and crew preferences are also embedded into the plan. What the crew sees is this other platform. So we built it in SCORE, but the crew sees it in Playbook. Playbook is a planning tool that NASA Ames developed, and they can access this through their tablets, and they just click on an activity, and at the right side they will see the procedure, a little bit more information about their activity, and they can access it through there. The tool also allows them to start their activity once they are performing, and also ending when that's done.
2 minutes.
So there are areas for improvement on that, on the communication and how they interact with the simulator. Some of the tests performed included these activities, and I want to get to this on the crew metrics. So we use that Playbook tool that I mentioned to look at how satisfied and the crew was and accepted that, and there's different definitions on that you can look in the paper. But also to compare the planned task durations to the actual task durations that they spent in different activities. These are the results, and the gray part is what was planned, the red is what they actually spent time. There are some outliers like the meal time. Those are the middle ones. Is they reported like 5 minutes to 10 minutes, but what we account for this is they forgot to click on the start progress and end progress. So there are things that we were tracking that the tool might need to help us better with. Most of the activities were completed in less time than what was planned, but there were some that they couldn't complete, and that was because of the test procedure, not because of the operator. So some conclusions, playbook help us to capture the timeline deltas to determine what affected the crew and not, but we still need to understand these two better. And we met some commanding telemetry and planning operation goals, but there's still room for improvement. Like I said, the procedures especially need to have higher fidelity and consistency. Subject matter experts usually were from the engineering or human health and performance groups, and they didn't know how to work with from the operation side. So we're working on that, and we are currently doing some tests right now where we apply those lessons learned for the upcoming tests. Right now, in 2 weeks, when I go back, I get to do another crew test at the end of October, and then we're going to be starting with the companies next year. So it's an exciting time, and if you want some references, I invite you to look at the paper, and for any questions, I'm here. Thank you.
Thanks. Questions for Jackie? I have one. Oh, good. Okay, yours are more important.
Is this app for mission planning available for usage of external parties?
The tool, you mean?
Yeah.
Yes, a playbook from Ames, they made it available. I don't know to what level, but you can find that online.
There was another one.
Yeah.
Is that the next step mission where you are dealing with more private companies like Bigelow, but the habitat that you are testing, it's not one of their.
That's correct. Yeah, it's not gonna be ours. We're just having that as a skeleton for us to get prepared to test the rest. Yeah, that's correct.
That's actually related to my question. So each of the I guess six partners, 5 or 6 depending on how you count, is going to be sort of cycling through and participating physically with their mock-ups in this facility, or how does that actually work?
Yeah, I think 3 of them are coming to Jesse, bringing their own structures into the same building. We'll be connecting it with our ground systems and testing it there. 2 of them were going to their facilities and test their structures there. So that's another coordination that we're preparing for also internally to bring our ground systems to their facilities.
Great.